This is a percent problem where we want to know the least possible integer for which 40% of that integer is greater than 1.8. Well, let's just work in reverse. Let's find out what equals 1.8. Remember, with percentages, it's best to work with them as decimals. So 40% is 0.40 times x equals 1.8. If we divide both sides by 0.4, we get 1.8 divided by 0.4. So x equals 4.5. We remember that an integer is a positive and negative whole number, or 0. The least integer greater than 4.5 is 5. We can double check this. 40% of 5 is 2. Here we have a classic SAT percentage problem. They increase the price of a dress 10%, then they decrease the price 25%. Work with decimals here, and remember, your starting point is always 100%. 100% is represented as 1.0. If you increase 10%, you want 110% of the price. If you decrease 25%, you want 75% of the price. Do your work on the decimal side. These problems aren't hard. So we want 75% of 110%, the new price. And 0.75 times 1.10 is 0.825, which is 82.5% of that original price. See, math is easy on this as long as you keep it in decimals. Percentage problems are not difficult as long as you use decimals. In this case, we're just going to walk this through. Line out what they're saying. 20% of Q is 30. And then we want 30% of Q. So if 0.2Q is 30, Q equals 30 divided by 0.2, which is 150. So then we just take 30% of 150, which is 45. It's not that tough as long as you segment it and just walk it through. This is a pretty tough percentage problem until you realize you just work with it on a percentage basis using decimals. In this case, we've got, if a customer buys an inner tube at full price, they get a 70% discount on the second tube. She buys 2 inner tubes that have full prices of $8 and $12. By what percent will her total purchase be reduced? Remember, 100% is simply 1.00. So if we've got a 70% discount on the second tube, heck of a discount, you're only going to be paying 0.30 for that tube. She will have to pay $12 for the first one, because remember, the 70% discount is on the second tube of equal or lesser value. So she's going to be paying 30% of the $8 tube. Well, 0.3 times $8 is $2.40. So she's paying $12 plus $2.40, which is $14.40. Normally she would have been paying $12 plus $8, which would have been $20. So we subtract the difference and find out she's paying $5.60 less. And $5.60 is 28% of 20. Remember, you divide 20 into 5.6 to find the percentage. Here we have a problem where we're going to be increasing the length and width of a rectangular image by 50%. Then we're going to decrease that new image by 20%. An increase of 50% means you add 50% to 100%, so it's now 150% of that original size. We're now going to decrease it 20%, which means we subtract 20% from 100%, and we're looking for 80% of this new size. 80% of 1.5 is 1.2, or 120% of what it was originally. Be very careful. This is question number 25, which means it's a difficult question. And there's got to be a twist to it. The twist is they want the area of the final image is what percent of the area of the original image. We've increased the length and width by 20%. So we want the area, we've got to multiply 120% of the width by 120% of the length, which gives us 144% of what that original area would have been. 1.44 minus 1.00, we've got a 44% increase.